Welcome to this first lecture on a very important function of buildings' facades, which is ventilation through the windows or even the walls. In this lecture, we will address how to design facade ventilation in order to support a healthy and comfortable building and to reduce the energy demand. In other lectures, extensive attention was given to the design of healthy mechanical ventilation systems for a good indoor air quality. This is very important as many buildings over the world are equipped with such systems. These systems are needed to bring enough fresh air into buildings with a high density of occupants, like hospitals, offices or schools, like on the picture on the right. Mechanical ventilation is also applied in buildings in which, for some reasons, like safety or too high wind velocities, the windows cannot open. High-rise buildings, for instance, see pictures on the left. There are also buildings in which air is used for heating or cooling, so-called air conditioning, and they also use such mechanical ventilation systems. But many other buildings combine such a mechanical ventilation system with a natural one, or even are completely naturally ventilated, just using windows, like in the two pictures left, or ventilation grills in doors or walls, like on the third picture, but mostly in windows. Modern grills, like the one on the right, are pressure regulated, meaning that when there is a lot of wind, the grill will close automatically a bit more in such a way that just enough air flows in, avoiding draft and too much heat loss or gain by ventilation. So, in these cases of ventilation through window or facade, the indoors is somehow in direct contact with outdoor air. In general, it gives people a sense of being in control of their environment and to be connected to outdoor. We already touched on that in a lecture about adaptive thermal comfort. By giving people control on the opening of the windows, they can accept higher indoor temperatures when it is hot outside, in moderately warm climates at least. However, opening windows may also be a source of potential burdens that we, building designers, have to take care about. Take a few seconds to think about potential problems. Of course, in an environment like the one on the picture, a house located in a quiet street, little traffic, a green park across the street, little problems can be expected from the outdoor. But in many parts of cities, the outdoor environment is much more like this one. In such a busy street, there is air pollution by traffic and there are a lot of noise and vibrations. Both have been seen in earlier lectures as extremely important for the indoor environmental quality. We will therefore address specifically the ventilation possibilities with regards to outdoor air and acoustical qualities, how to come to a good design of the natural ventilation system. Next to noise and air pollution, there are other parameters to account for, such as the climate. Evidently, the use of windows for ventilation is not the same in a moderate warm climate where a continuous opening is possible, like on the left with the windows ajar. In a cold climate, this would produce draft, which is very uncomfortable, as we have seen in earlier lectures. Furthermore, the issues of safety should not be forgotten. First, at ground floor level, the ventilation openings must be somehow burglar-proof. See here a top-hung swing window and a window with a fence. Second, at higher floors, if windows are to be opened, there must be a fallout protection, like a balcony left on the picture or a fallout fence, like on the window's right. You may remember from other lectures that in buildings we should always account for 25 to 50 cubic meter fresh air per person per hour, which, depending on the ventilation effectiveness, correspond to 6 to 13 liters per second. You also have learned about different air distribution patterns for mechanical and natural ventilation. Only the natural ventilation is depicted here. Whatever you are using, a window or a grill in a window or a grill in a wall, it is important to ensure this minimal airflow rate. The amount of air coming in depends on what we call buoyancy, which is the fact that warm air goes up and cold air down, and it also depends a lot on the wind pressure on the facade. You can imagine that in a situation where the wind comes from this side, the ventilation flow rates are okay in both configurations, although the cross ventilation will be more effective as there is a larger pressure difference between inlet and outlet than in the case of only one window at one side. However, if the wind comes from the opposite direction, the cross-ventilation arrangement will work as well, while the one-sided configuration above will not allow for enough air. This can be somehow improved by having more windows on the same side, forcing this way the air to change direction, providing ventilation to a larger area. You see here a wall with 2 windows. However, whenever possible, cross-ventilation should be preferred. This can be realized within a building by taking care that air can move from one room to the other. Therefore, ventilation openings must be realized by having grills in indoor doors or walls, or at least by taking care that there is a space left between the door and the floor. You see on the drawing a configuration with 2 rooms around the corridor and ventilation grills from the rooms to the corridor. On the picture, you see ventilation grills from a classroom to a corridor adjacent to an atrium. They have been placed next to the door. Note also that it is often preferable to aid natural ventilation with either an exhaust or a supply fan. That will help to ensure a continuous flow of air, especially when there is no wind. Such a fan can be placed in the chimney. That is what is called mechanical exhaust or mechanical supply ventilation. Especially when using grills, it is very important to make sure they are not obstructed. This is a special point of attention in combination with solar and light blinds. The pictures on the left show indoor solar blinds. In the left one, the grills above have been kept free, which is good, while in the second one, the blinds are covering the grills. On the right, you see configurations for outdoor blinds. The configuration in the third picture allows for air flowing between the blinds and the grills, while the configuration on the right is detrimental to the ventilation. We have seen a few slides earlier that in many urban configurations, noise and vibrations from traffic, people, or construction works may be very disturbing. Well-insulating windows with more glass layers of higher thickness and with cavities filled with gas or vacuum help enormously with thermal and acoustical insulation. Sound insulation of windows can be improved by increasing the mass of the window frames and perimeter infill, improving the airtightness of the perimeter construction, placing sound-absorptive materials or high-mass materials at the perimeter of the windows. On the picture, you see such a typical window frame for a passive house, which is an extremely well-insulated house, also from sound and vibrations point of view. Above in blue, the 3 layers of glass, and below the frame, very thick and massive, with cavities. Unfortunately, this doesn't help very much when the windows need to be open for ventilation. As already mentioned, ventilation grills placed in a window, window frame or wall can also be used. Sometimes they are called vents or trickle vents. These grills are open to outdoor, so they also let outdoor noise comes in. However, there are nowadays many grills equipped with acoustic protection and air filters. In the 2 first pictures, you see the acoustic insulation in 2 different types of grills. The airflow from outdoor to indoor is given in purple. In the third picture, a filter against pollens and particulate matter is placed. Such a filter must be replaced or cleaned regularly. These grills, when correctly designed, also ensure a quite low air velocity and much less draft than with simple window opening. From other lectures about mechanical ventilation systems and air handling units, you probably remember that one of their strengths is the possibility to apply heat recovery between the cold air coming in and the warm air leaving the building in cold climates, that is the picture below, or between the warm air coming in and the cold air leaving the building in hot climates, as in the picture above. In these heat recovery systems, the incoming and outgoing flows are not mixed, which is very good for the air quality. There is just exchange of heat through a plate. This can reduce the heating and cooling needs in the ventilation itself by 60 to 80%, resulting at building level to a reduction of heating or cooling needs between 10 and 30%. To do so, you need pipes bringing the air into the heat exchanger and ventilators, which cost some electrical energy. This is not achievable with natural ventilation systems as there are no ducts. However, there are nowadays facade grill systems allowing heat exchange. See here an example. The pipe is worked out in the facade and the ventilation is assisted by a fan, so this costs a little bit of electricity, but allows for recovery of thermal energy, just like in an air handling system. A well-insulated facade is not only helping for thermal insulation, but also for acoustic insulation. The higher the mass of the facade and the more insulation materials are used, like mineral wool, glass wool, etc., the better it is. However, many architects have a preference for glass facades. Glass in itself is not very helping with soundproofing, unless multiple layers are used and specific frames, as we have seen 2 slides before. A specific solution consists of using an additional glass envelope around the window or even around the building itself, as you see on the right side, where the cavity is broad enough to allow for people to walk on it. Sometimes the inner glazing is double and the outer is single, sometimes it is the opposite. The double-skinned facade provides this way additional acoustic insulation against noise from outside. However, indoors, acoustic materials should be used because glass is a hard material, so the acoustic quality indoors may be poor if no measures are taken. The double-skin facades also provides ventilation through the cavity. It can even provide a kind of preheating of the air when the sun shines on the cavity. These facades are said to be smart because they can be controlled on different ways. See a few examples here. First, in a situation in hot season where after a warm day the rooms are quite hot, but it is becoming night, so the outdoor air becomes fresher and can be circulated in the cavity where it will take the heat away from the warm double glazing. This way heat is removed by convection, which helps with cooling. Additionally, the glass temperature decreases, by which the mean radiant temperature MRT inside also decreases, making the room more comfortable. The second possibility is for a cold but sunny day. The cavity acts as a greenhouse, passively heating the cold outdoor air, which can then be supplied to the room at a nice temperature. Third, during a cold and overcast day without sun, the indoor room air can just be exhausted through the cavity. As the air is warm, it will heat up the double glazing, the temperature of which will then increase, increasing here to the MRT. It will also decrease the heat losses by transmission through the double glazing, as the air in the cavity is warmer than if the indoor air will not be circulated. And finally, a configuration for hot days. The solar blind can be located in the cavity, which is easy for maintenance and avoids problems with wind, while having the thermal advantages of outdoor blinds. The heat is not penetrating into the building. Because the solar blind is absorbing a lot of solar radiation, it could become much too hot, which is prevented by ventilating the cavity with the less hot warm outdoor air. Those were only a few of the possibilities. In this lecture, we discussed the role of facade elements for natural ventilation and how it relates to acoustic quality, air quality, thermal quality, and finally, energy demand. For enough fresh air, natural ventilation may be used instead of a complete air handling unit, especially in buildings with low occupancy. Windows can ensure ventilation, but it is also possible to use grills placed in the facade or in windows, ensuring this way less draft and more safety. Although it is in general recommended to support natural ventilation with either a supply or an exhaust fan, there are configurations like cross ventilation that help to ensure a continuous airflow. Care has to be taken that the grills are not obstructed, and in noisy or polluted outdoor environments, acoustic insulation and air filters should be placed in the grills. Air filters must be replaced or cleaned regularly. Heat recovery from indoor air is a very efficient energy-saving measure that needs mechanical ventilation. Air recovery is in general not applicable to natural ventilation systems except for some heat recovery facade units. We also discussed some features of double-skinned facades and windows that help to provide acoustical insulation from noise from outside in fully glazed buildings, but care has to be taken of indoor acoustical quality. These facades also give many smart possibilities to control airflows in such a way that surface temperatures and heat losses and gains are better controlled. Thank you for listening to this lecture.